Greetings, I am Cartreal Davidson, a second year chemical engineering student from Pascagoula, Mississippi, and I was given chapter 14.7, which is extreme and local maximum and minimums. Local max and local minimum. The local maximum, it corresponds to the mountain peaks of the graph, while on the other hand, the local min corresponds to the deep valleys and the lowest points of the graph. Here's the definition of it, of the local max and local min. If FAB is greater than or equal to f of xy for all the domain points, then f of AB is a local minimum. If f of AB is less than or equal to f of xy for all the domain points, then f of AB is a local minimum. And right here I have a graph that I'd like to show you where you see multiple, on this graph y equals f of x, you have multiple local maximums. So you have one right here, and right here, and then you also have local minimum points, which is right here, and then you have one right here where it's kind of cut out right there. That's a local minimum points. So as you see on this, you can see your two local max and local min points. Also, we use the first derivative to find the local maximum and local minimums. With the first derivative, it is used to find the critical points. And right here, to find critical points, like I said, you must take the first derivative. But since you have a multi-variable function, you have to take the derivative of both with respect to x and y. So I have a function right here for an example, which is f of xy is equal to x squared plus y squared minus 6x plus 7. So I have to take the derivative with respect to x, which is fx. F with respect to x, which is 2x plus 6. And the derivative of y with respect to y, which is fy, is 2y plus 6. And we set these equal to, we set both equations equal to 0 to get our critical values. And these critical values will tell us where our local min and local max points are. With the second derivative test, we use this also to find the local min and local maximum. So we have rules right here that give you each scenario or each rule set gives you a different aspect. So for the first one, you use this one to find a local maximum. The second one is used to find a local minimum, while the third one is used to find a saddle point, and the last one is used to see if the text actually works. So if you end up with f of x, f of y minus f of xy squared, and if that equals 0, then the test failed. Lastly, absolute maximum and minimum. Just like in the previous slide, we was talking about critical points and f of xx and f respect to x and f with respect to y. The critical point, you have to find the critical points, and you have to set f of x and f of y equal to 0 to get your critical points, like I said. And also you have to use a closed region to find where you're going to have your local min and local maximum points. And with this, you have to set up a t-table, which is x, y, and z. This is a multivariable function. And once you find your points, your border points, you're going to use this to the t-table to find out your z. So you're going to plug all your points in, and with this being used, you'll be able to find your your extreme max and your extreme minimum. And that is the end of the presentation. Oh, excuse me, I'm sorry. I have a graph right here to show you the extreme, the absolute maximum and absolute minimum. So right here I have two absolute maximums, and then on the bottom I have an absolute minimum. That concludes the presentation.